All right, guys, so this is Thursday, and we are going to be reviewing what we learned Monday, Tuesday, Wednesday today. I'm going to go over 6 of your homework problems that last couple years people have had questions on. Those are 13, 17, 19, 21, 23, and 37. After that, I'll talk about a couple more things, but then we'll look at some practice AP questions. These AP questions are free response. They should not overwhelm you. They are so direct to the point. Here's a slope field. Plot some slopes on the slope field. Can you separate and integrate? Can you solve using initial value for that plus C? There's no randomness to them. There's no like, what is this even asking? It's pretty straightforward. So we're going to look at a couple of those. And then you have your test tomorrow. Okay, remember, Shafi and Porbet are here for you guys. If you have questions, go find them. Get help from them on it. But hopefully today is pretty self-sufficient for you. As for the test tomorrow, first page will have 8 separate and integrates. No funny business to it, just separate, integrate, separate, integrate. You will not have to solve for the C, so there will be no initial condition, but you will need to get it to be y equals. So you're going to have to do some fuzzy math on that C just to get it to be a y equals. But 8 problems, separate, integrate, very straightforward. The next page, page 2, will have 2 problems on it. One will be a growth and decay type problem, and one will be Newton's law of cooling. Now, these questions could have been written for an Algebra 2 test on this second page, but I do want you to start with the differential equation and then solve it for the equations. So what that means is you would start with like dy dt equals ky. Then you need to show your work to get y equals c e to the kt. And the other one would be dy dt equals k y minus ym. And you're going to need to show your work that it becomes this. On Algebra 2, they just gave you this. Whoops. And you could solve the problems. For you, I'm going to give you nothing. You're just going to read the problem and go, oh, it's that. It becomes that, and then you keep solving. Or, oh, it's this, it becomes this, and it keeps solving. Now, when I say it becomes that, you don't just get to draw me a red or a green arrow from this to that. You actually physically need to separate, then integrate, and have it written out for me so I know you can set up the equation, then you can use the equation. Last page, 2 AP type questions, similar to the ones that we'll look at today. Okay, so that's the flow of things. All right, so here's first one, number 13, that you had in homework last night, and I'll just go about trying to solve it for you. Anytime I have y primes, I like to write them immediately as the dy dx. And now my goal is to get all of the y's on one side, all of the x's on the other side. Typically, the y's are on the left, and the x's are on the right. In this case, this one actually is going to be backwards. My first step is I'm going to move over the second half of the blue. And then I am going to do this. Remember, there's 2 options here. Some of you might go, well, y's are always on the left, so you would have y over dy equals x over ln of x with a dx on the bottom. You did separate that, that is correct, but you cannot integrate this because you can never have the dy's or the dx's on the bottom. So instead on this one, what this is going to become when you separate it is you're going to get ln of x over x dx equals dy over y. It's basically the red guy, you're just looking at it upside down. Okay? You can only do the black one. Now, if you want to do the black one and you wish the y's are on the left, you can rewrite it. You can definitely rewrite this and say, all right, this is dy over y equals, no, over here. Dy over y is ln of x over x dx. Now it's time to separate. Now we can integrate. That's ln of y. That's easy. The right side, some of you might go, uh-oh, I do not know how to do this. So first off, one of your issues might be you might not know how to separate. That's an algebra skill, separating. The next part is the calc part, the integrating part. And you might go, yikes, I don't know how to integrate this ln of x over x. This is a u sub. U would be ln of x. du dx equals 1 over x. du equals 1 over x dx. So this is a perfect fit. See how the x is in the bottom, the dx is on top. It's a perfect fit. So this is turning into the integral of u du, which is 1/2 u squared plus c, which is 1/2 ln of x squared plus c. So that is what fits over on this side. It's a whole u sub to get through it. That's kind of like the last test or 2 tests ago. You have to understand everything leading up to the current chapter that we're on. Now you've separated, you've integrated. Now we go back to algebra, and I need you to get it to be a y equals. I'm going to e both sides. Y equals ce to the 1/2 ln of x squared. That 2 on the square cannot fall down because it's not ln of x squared, it's ln of x, all of that squared. Okay? So some of you might have an issue with separating. Some of you might not like having the y's on the right side. Some of you might have done the left one and said, I don't know how to do that when a dy or dx is on bottom. We'll flip your head upside down and you can use it. And some of you might have struggled with the u sub idea. All that's fair game on that first page. Okay, let's look at this one. Okay, this one now gives you, I think, an initial condition of y of -2 equals 1. And I need to solve. Let me check one thing real quick. I just made sure that that was the initial condition. I thought I wrote it down wrong. Okay, this one would be another question on the front page. It just would not have this part to the front page. Okay, this one would just have the separate integrate part for the test. First thing I would do is I do not like the y prime, so I like to write it as dy dx. To get rid of that plus sign in between, I'm going to go dy dx equals -y x plus 1. I moved all of that chunk over. Then from there, I'm going to divide by the y, not the negative, just the y. And I'm also going to multiply by dx. So you are going to get it to become dy over y equals -x plus 1 dx. Okay, so subtract it over, divided the y over, multiplied the dx over, you're good to go. Now, some of you might prefer distributing that negative now and saying -x minus 1 dx. You might just feel comfortable having that. So when you separate, now you're allowed to integrate. You get ln of y, absolute value, is, let's see, -1/2 x squared minus x plus c. I can e it. The absolute value goes away because I'm going to have the fuzzy math. I get that. Now some of you go, wow, how'd that work? Well, remember, this is, I could have it e to this, e to this, e to this if I wanted to, because remember when you're multiplying, you can add the exponents. But the e to the c guy is the only one that's the fuzzy math, so he becomes the c. And these two guys are all with x's, so I kept them clumped together. So you have that. The absolute value went away, remember, because when you e it, you can handle that plus or minus when you use the c, when you plug in -2 and the 1. So now I'm going to plug in -2, comma 1. I get 1 equals ce to the -1/2 -2 squared minus -2. And I'm going to get 1 equals ce for -2 plus 2. 1 equals ce to the 0. 1 equals c. So then now I have my guy as y equals e to the negative 1/2 x squared minus x. Okay, there's the next one. Let's look at number 19. Again, this would be just like the front page of the test. You would not have the initial condition though. You'll have those initial conditions later in the test. Let's try this one out. Okay. First step, y 1 plus x squared dy dx. Moving over the negative guy, x 1 plus y squared. Separate, so I'm going to get dy a y 1 plus y squared equals x dx 1 plus x squared. That's algebra skills to get to the separate part. Now you're going to integrate it. Now, here's the issue. If you don't know how to integrate the left side, you don't know how to integrate the right side because they're the exact same guys, just in terms of x's and in terms of y's. Again, this is a U sub. Again, you need to know prior materials in this calc course. The thing I see right away is there's no overall exponent on either one of these. So this is going to go to ln of 1 plus y squared. I might be off by something. ln 1 plus x squared plus c. I might be off by something. Remember, there's no exponent on the overall bottom, so I can say it's an ln right away. Now I just have to decide what I'm off by. The derivative of y squared is 2y. I have a y up top, but I don't have the 2 up top. I don't want the 2 up there. So I'm expecting a 2y up top, but I only have a y up top, so I must be off by a half. On the right side, exact same thing. The derivative of x squared is 2x. I don't have 2x, I only have 1x up top, so I must have multiplied by a half. Okay. Now, if I was to solve this for y, there is some fuzzy math to be had. I do not want to e it first. Instead, I'm going to multiply by 2 to get rid of the halves. ln of 1 plus y squared equals ln of 1 plus x squared plus c. The reason it's just plus c again is fuzzy math. 2 times c is c. Now I can e both sides. And I'm going to get 1 plus y squared equals, I'm going to write it this way first for you to understand it. ce to the ln of 1 plus x squared. Realize though, on that right side, the e to the ln cancels. So I got 1 plus y squared equals c 1 plus x squared. The e and the ln cancel down to that. Okay. Then if you wanted to keep going, which you will have to do on the front page, you could go y squared is c 1 plus x squared minus 1. And y equals plus or minus, do not forget that, c 1 plus x squared minus 1. You need that plus or minus right now because you have not plugged in an initial condition. You've only solved for a generic solution. But I have here 0 comma square root of 3. So 0 comma square root of 3. When I plug that in, square root of 3 equals, I still don't know which one it is, plus or minus. I need to decide that. 1 plus 0 squared minus 1. Let's see, square root of 3 equals, I still don't know if it's plus or minus. C minus 1. Well, stare at that. It's square root of 3, so it must be the positive version. That's one thing I need to get. I know it's positive. Now I need to see that 3 equals c minus 1, so c equals 4. So my guy would be the positive version of the square root of 4, 1 plus x squared minus 1. Okay. Just keep going, plugging through these. Du over dv equals uv sine of v squared. U of 0 equals 1. And you might go, whoa, there's no y's, there's no x's, there's no t's. This doesn't make any sense at all. If you want in your head, you can think of this. We're so used to dy over dx. So it must be u is the same idea as a y. and v must be the same thing as an x. So if you wanted to, you could write this as dy dx equals uv y x sine of x squared, and then my initial condition would be y of 0 equals, whoops, y of 0 equals 1. It's the exact same problem. Instead of u's and v's, I did y's and x's. If you want to do that, you can. Okay? Got to separate dy over y, x, sine of x squared, dx. There's algebra. Now I'm going to integrate. This is ln of absolute value y. Another u sub. Okay? I can do this mentally. You might not be able to, which is okay. Look at what I first wrote. I know the integral of sine is negative cosine. I think I'm going to be off by something. So I wrote negative cosine of x squared, but I still think I need to add something in. So that red part would be my version of stamping, and the addressing would be what am I off by? Well, the derivative of x squared is 2x, but out front I only have x. So I'm expecting 2x, but I only have x. That must mean I'm off by a half. If you don't like what I did, could you take the derivative of that right side and just make sure it lands on the blue? Okay, that plus c. Then if you need to get y by himself, you could e it. Y equals c e to the negative 1/2 cosine of x squared. That would be what the first page would be like in the test tomorrow. The second part would be I still need to plug that in. So y of 0 is 1. So 1 equals c e to the negative 1/2 cosine of 0. 1 equals c e to the negative half. So c equals 1 over e to the negative half, which is e to the half. And then you could say y equals e to the half, e to the negative half cosine of x squared. Now notice those are both e to those, e to those. Since they're both e to those, you could say y equals e to the 1/2 minus 1/2 cosine of x squared. If I'm going too fast, you can slow it down and hit pause and kind of look at the work that I've done on each of these problems. Okay, 23 looks weird because there's no like dy over dx. There's just these like dp's. They're kind of like, where'd the other part of the fraction go? It's okay. Look what happens. I'm going to move the thing over first. And then I need to get that p on the other side. So I got dp over p equals k dt. Oh my gosh, you should know that this is the growth decay model. When you integrate, you got ln of p equals kt plus c, e both sides, p equals c e to the kt, and then it gives me an initial condition of this, which you can plug in and go p naught equals c e to the k 0, which gives me p naught equals c. Basically, the way you need to read that is at time 0, you have your p naught, which is called your initial population. So in this case, you would have p equals p naught e to the k t. Next one. Okay, now this one would be one that would be similar to the growth and decay problem that could be on the second page. Okay, this, I just solved this one on the previous one. You're going to separate, integrate, you're going to get p equals c e to the kt. Okay, I give you an initial condition here. That guy is going to get me the c. So p is 100 e to the kt. The way it worded it here is a half-life after 50 years. So if I started you with 100, half of 100 is 50, and it took me that long to get it. You're going to plug that into there and get K. And then once you have all of that, you can solve for what percent do I have left after 50 years. It's going to be close to 100% because it took basically 1,600 years to cut me in half. So 50 years didn't get me that far. So I'm expecting when you do that, maybe 98, 99, I don't know. But hopefully that's a good review of that. Okay, we got some more videos from some more review coming up on the next ones.